Hi, so today I will explain about the mechanism of nitration of benzene. So this is the overall reaction in this mechanism. The we have nitrobenzene as the starting material, react with concentrated nitric acid and forming of meta-dinitrobenzene and H2O. The catalyst is concentrated sulfuric acid on 50 to 55 degrees Celsius. So this is the first step in this mechanism, which is the formation of electrophile. In the first step, the hydrogen atom from sulfuric acid is transferred to nitric acid. As a catalyst, sulfuric acid facilitates the reaction by providing a medium conducive to proton transfer, but does not become a direct participant in the overall reaction. So in this step, nitrobenzene is not react with nitric acid first because nitrobenzene is sangat stable, so dia kena ada electrophile baru dapat react with the nitrobenzene. So in this step we will nitric acid as a reagent, dia akan react with the H2SO4, which is the catalyst in this reaction. This reaction between nitric acid and sulfuric acid, they akan form electrophile, which we will use for the reaction with the nitrobenzene later. So one of the lone pairs on the oxygen atom of nitric acid attacks the more electronegative hydrogen atom on H2SO4. H2SO4 is more acidic, so it is easy to release hydrogen. So after hydrogen is attacked by the lone pair of oxygen atom, this bond they akan weaken, so it will broken. After this hydrogen atom is attacked by one of the lone pair of oxygen atom here, this sigma bond it will be weakened and will broken. So both of the electrons are pushed towards the more electronegative oxygen atom. This produces H2NO3 plus and also minus. They are not stable, and they are the plus here because on this oxygen atom there are more one bond than usual. Then the protonation step forms natrium ion and bisulfate ion. This natrium ion is an electrophile which is responsible for the electrophilic aromatic substitution reaction with nitrobenzene later. So move on to the next step, which is the formation of aranium ions. So this is the aranium ions, and this reaction is a slow reaction. I will explain it later. Just a reminder, it is better for us to draw the benzene ring like this so that we can see the double bond, the pi bond, clearly. Okay, so this nitrobenzene acts as a nucleophile with its delocalized pi electron cloud. Delocalized means the electron inside this ring is always moving. Like this, they are always moving. So the electron-rich reagent of the nitrobenzene is attracted to the positively charged nitronium ion, which is the electron deficient due to the presence of nitrogen with two oxygen atoms. Therefore, two pi electrons of the nitrobenzene are pushed to the electrophile here. Nitrobenzene and other aromatic compounds are highly stable due to their delocalized pi electron system, which provides significant aromatic stabilization. Breaking this aromaticity by forming the sigma complex requires substantial energy, making it a slow process. The electrophilic bonds with one of the nitrobenzene carbon atoms breaking the ring's aromaticity. This results in the formation of a sigma complex, or we can call it as aranium ions here. This intermediate sorry these aranium ions uh, in these aranium ions, the positive charge is delocalized over the nitrobenzene. Dia akan delocalize. The aranium ion is a resonance stabilized carbocation intermediate. The positive charge in the aranium ion is delocalized over the aromatic ring through the resonance, resulting in multiple resonance structure. So since it is a resonance, we must draw this arrow. This arrow shows that this is a resonance. So in these resonance structures, the positive charge is shared by the carbon atoms of the ring and stabilized by the electron cloud. And these aranium ions are unstable. Oh, and also untuk lukis aranium ion, you must draw this bracket. So this is the last step in this mechanism, which is the protonation of aranium ions, ataupun deprotonation to means that removing proton. After the formation of aranium ion, a positively charged carbon atom is within the nitrobenzene. This positively charged carbon atom is often adjacent to a hydrogen atom on one of the ring carbons. The negatively charged also minus ion can act as a base and attract a proton from the carbon atom adjacent to the positively charged carbon atom in the aranium ion. So means that ini dia akan attract proton yang dari sini, and ini dia akan broken down and form a new pi bond here. So since also minus is negatively charged, they are attracted to the positively charged of hydrogen atom here. So they akan attack proton in this, and the sigma bond they akan broken down, and both of the electron will be pushed to the carbon, which is more electronegative than hydrogen. So it will form a new pi bond here. The proton transfer forms a double bond between the carbon atoms, restoring the ring's aromaticity. This step involves donating electrons from CH bond to the positively charged carbon atom. Means that from here they akan donate electron to carbon here, and it will form a pi bond, just like what I told you just now. So this is the new pi bond form, and the formation of the double bond effectively restores the aromatic character of the ring, completing the rearomatization process. The resulting intermediate is often a substituted aromatic compound where the electrophile has been incorporated into the ring, in this case metadinitrobenzene. or we can call it 1,3-dinitrobenzene. 1,3-dinitrobenzene. In the nitration of benzene, H2SO4 acts as a catalyst, and therefore, at the end of this reaction, the structure of H2SO4 is recovered and H2O is byproduct in this reaction. So that's all from me. Thank you.